convex and concave lens. So this sign convention is very useful whenever we solve some numerical problems regarding convex and concave lens. So I have drawn the sign conventions here for both the lenses. Let me explain for both the lenses together. So whenever you are considering the measurement of distances, the optic center must be chosen as the origin of the coordinate system. Now, origin of the coordinate system is from the optic center only you need to measure all the distances in case of convex and concave lens. Suppose you want to measure the focal length, you want to measure the object distance, you want to measure the image distance. Okay, so from the optic center only all these things have to be measured. So here for both the lenses I have indicated optic center, and remember from this point only you have to measure all the distances. And usually we will consider the object to the left of the lens. So here I have indicated a small linear object to the left of the lens, and from this object light rays will be traveling towards the lenses in case of convex and also concave lens. Now here I have indicated the direction of incident light for both the lenses. Is it not? The direction of incident light. So remember, whatever distances you are measuring in the direction of incident light must be taken with positive sign. So here I have indicated positive. See here, this is positive sign, this is also positive sign. Means this, check the direction here. We are measuring the distances in the direction of incident light. So in this direction you are measuring any distances, that should be taken with the positive sign. And one more direction I have indicated, direction opposite to incident light. So whenever you are measuring the distances opposite to the direction of incident light, then it must be taken with the negative sign. Okay. Then above the principal axis, xy is the principal axis in both the cases. Above the principal axis you want to measure any distances, means you are measuring the height of the object or the height of the image, then it should be taken with the positive sign. Okay. And below the principal axis you are measuring any distances, then it must be taken with the negative sign. Okay. So remember, all the distances have to be measured from the optic center of the lens only, and in the direction of incident light, whatever distances you are measuring, it should be taken with positive sign. Opposite to the direction of incident light, it should be taken with the negative sign. Above the principal axis, use positive sign, and below the principal axis, use negative sign. And also remember, f of convex lens is always positive. Okay. Then f of concave lens is negative. So this is another important point you have to remember. Already we have discussed, in case of convex lens, the principal focus is a real point, whereas in case of concave lens, it is a virtual point. So f of convex must be taken with the positive sign, and f of concave must be taken with the negative sign. So this is the simple sign convention you have to follow whenever you are measuring distances in case of convex and convex lens. Concave and convex lens. However, when we solve the problems, we will understand this much better, because we will be taking either plus sign or negative sign behind the number, means behind the distance of the image of the object. Okay. Please note down these important items. Okay children, after knowing about the sign convention for measurements of distances, you should also remember that all the distances must be measured along the principal axis of the lens only. Understood? And next is the lens formula. So here the derivation of lens formula is not required for the scope of the syllabus. You have to just remember what is the lens formula. So lens formula is 1 by v minus 1 by u is equal to 1 by l. This is the lens formula, okay, where u is the object distance, then v is the image distance, f is the focal length of the lens. So for both the lenses, either you take the convex lens or concave lens, the lens formula remains the same, and it is 1 by v minus 1 by u is equal to 1 by l. So whenever we are solving numericals on the lenses, then the known quantities must be taken with the appropriate sign. Okay, so among this, any two known quantities will be there and one unknown quantity will be there. So all the known quantities should be taken with the appropriate sign based on the sign convention. Then after solving the numerical, based on the answer we are getting, along with the sign we can decide whether the image is real, okay, or virtual, whether it is focal length is positive or focal length is negative. You can decide about the nature of the lens also. Okay, so this is about lens formula. The next small topic is linear magnification. So what is linear magnification? Linear magnification is denoted by the letter small n, and it is the ratio of length of the image to the principal axis, perpendicular to the principal axis, to the length of the object. So usually image and object, as I have told you, we will consider linear objects, correct? Above the principal axis and below the principal axis, I have given you the sign convention also. So the image can be either virtual image or real image. Based on that, it can be erect or inverted. So if you take the ratio of the length of the image to the length of the object, that will give you magnification. Okay, and it can be also shown to be equal to V by U. So remember, I by O will be equal to V by U. This is about magnification, and it can be derived that the magnification for both the lenses will remain the same in spite of the sign convention. Understood? M will be always equal to I by O, that will be equal to V by U, either for convex or concave lens. So this is one important formula you have to remember. Lens formula, then magnification formula. Now there is some sign convention even for magnification of an object. See, what is magnification? Sometimes the image can be highly enlarged, is it not? Or otherwise it can be highly diminished. So based on that we can decide what will be the magnification. I have some conventions here for real image. Real image always it will be inverted, we know that. So M will be negative only. The magnification will be negative. For virtual image means the erect images, M will be positive. Okay, so this is one rule you have to remember. Then for convex lens, M can be positive as well as negative, because for convex lens we are getting real images and also virtual images. I have discussed in my previous video that the last case of convex lens, if the object is between the first principal focus and optic center of the lens, then we will get virtual image. So remember, for convex lens, M can be positive as well as negative. Understood? For concave lens, M is always negative. That you have to remember. Next one. The value of M will be greater than 1 for magnified image. If the image is magnified or enlarged, then the value of M will be greater than 1. If the image will be the same size as that of the object, then M will be equal to 1. If the image is highly diminished, then M will be less than 1. Understood? Then for concave lens, M is less than 1. For convex lens, M is less than, greater than, or it can be equal to 1 also. So these are the some sign conventions you have to remember in case of magnification also. So all these are very important. So for real image, M will be negative. For virtual image, M will be positive. For convex lens, M can be positive as well as negative. For concave lens, M is negative. And the value of M can be greater than 1 for magnified image. Same size, it will be equal to 1. Diminished image, it will be less than 1. And for concave lens, M is less than 1. For convex lens, it can be less than, greater than, or equal to 1. Okay, so this is about linear magnification. So, even lastly, what we can conclude, what is linear magnification? Linear magnification is the ratio of length of the image to the length of the object, and it can be even shown to be the ratio of V to U. Okay, what is V? V is the image distance and U is the object distance. Next, in important small topic, that is power of a lens. So what happens to the incident light when it passes through lens? The incident light will undergo deviation when it passes through lens, because the light will undergo refraction. There will be a change in the speed of light. So whenever light passes through a lens, there will be deviation, and that deviation is due to the refraction of light. Is it not? And that is a measure of the power of the lens. Okay. So power of a lens, P is equal to, power of lens is denoted by the letter P. So what is the formula you have to remember? P is equal to 1 by F in meters. So you have to consider the focal length in meters. Understood? So this will be the formula. And the units for power of the lens is diopter. Or you can write it as capital D also. Understood? Diopter, and the symbol is capital D. And you have to remember the power of convex lens is positive and the power of concave lens is negative. Okay. So these are the very important points which you have to remember whenever you solve numericals based on the lens formula or magnification or power of a lens. Thank you, children.